In the last class, we have introduced about fuzzy set. Okay. So, although in giving some examples, okay. So, now you know about the distinction between your crisp set and fuzzy set. So, we did for fuzzy crisp set, there we have the membership function or the characteristics function. For this case, we wrote this as, suppose I write mu for this membership function and A is the set, crisp set, mu A is a function from x to 0 1 set. That means, it can have the value either 0 or 1. That was your crisp set for crisp set. Okay. For fuzzy, we have the membership function. So, I told that we will denote this fuzzy set as A bar. When it is bar, then it is fuzzy, mu A bar. So, this will be a function from x to closed interval 0 1. That means, it has this membership function value will have infinite number of points between 0 and 1 and including 0 and 1 also. So, when it is not included, exactly not included, then it is 0. If it is wholly included, it is 1, and in between that we have infinite number of points depending upon your problem. Okay. Now, this is your membership function. Now, what about fuzzy set? Fuzzy set is defined as, actually this is a ordered pair x and mu A bar x, okay, such that x belongs to your universal set x. We are understanding. That means, in fuzzy set you have two components, one is your x element and its membership function. Okay. So, these are the ordered pair x and mu A bar x. So, in this way we defined a fuzzy set. Understood? Now, let us take some examples. So, I am erasing this. Okay. So, if we have, suppose the universal set x I take as 1, 2, 3, 4, 5, 6, that means set of positive natural numbers, okay, 1, 2, 3, 4, 5, 6 dot dot. Now, if I define a fuzzy set A bar as 2 or so, means number 2 or so, okay. So, what you can tell me about membership function of 1? Membership function of 1. If your universal set is this, I am defining this fuzzy set as 2 or so, okay, 2 or so. So, then it is your choice. I can have mu A bar 1 as maybe 0, if you are taking 2 as exactly 2, but it is written 2 or so. I can write, because it is fuzzy sense. So, mu A bar 1 as 0.5, okay, mu A bar 2, it is exactly 2. So, what should be the membership value? 1, okay, mu A bar 3, again you can take 0, but it is fuzzy sense, I can take it as 0.5, okay. Like that, I have mu A bar 4 as should be 0, okay. Then others also mu A bar 5, 6 all will be 0. So, these are the membership grade or degree or whatever you can say, membership value or degree are like this, okay. Now, the fuzzy set A bar I can write like this. See, I told that fuzzy set will have two components, one is the element and its membership value, membership degree. So, I can have for 1, I will have 1 0, okay, 1 and mu A bar 1, mu A bar 1 is, sorry, if I take 0 then it will be 0. So, this is your 0.5. Similarly, 2, 1, 3, 0.5, 4, 0, like that, 5, 0. So, this is the fuzzy set that you will get for this 2 or so. 2 or 2 approximately 2, suppose approximately 2. 2 or so means you are not defining this fuzzy set as exactly 2. If it is exactly 2, it is crisp, means it is near to 2. Okay, see, if I define suppose 0, 1, 2, means if I suppose 2, if it is crisp, so you have 2 value, means single value here. If it is 2 or so means you can have like this. Again it depends upon your choice. You can have this width like this also. That is why I have taken 1 as 0.5. You can have this 2 as like this, that yesterday we defined. So, this is 2 for 1 and others are 0. Okay? This is an example that we are taking fuzzy set as A is equal to 2 or so. Okay? So, you will be more clear when I take more examples. Okay, so this is the way that we write the fuzzy set depending upon your membership functions. Okay? Now, there are in many books they have also written in another way like this also. First they write the membership function and below this denominator they write the element and they use plus, then 1 by 2 plus 0.5 by 3 plus 0 by 4 plus like this. But remember, these are not division, just representation, and these are not addition, these are union actually. Okay? This is not your usual addition, these are union, and this is not your division. Okay? Not your division, only it is the representation that the numerator is membership value and this is your, these are your elements. Okay? So, in symbolic form that means A bar I have x mu A bar x form, okay, or I can write this in symbolic form as summation mu A bar xi by xi, but remember it is not actually by. The numerator is your membership and this is your element. Okay? So, this is actually in discrete case. Similarly, if it is continuous, I can write this in terms of integral, but remember it is not integral actually. These are symbol that it is continuous system. Okay? So, integral mu A bar x and numerator x. These are all representation of the fuzzy sets. This is for standard, usually this we follow, sometimes this also we follow, or this is for discrete, this is for continuous. Okay? Now, coming to another example. Suppose I have the universal set. Okay, if I say the fuzzy set as John, a person, is young. John is young, and we had discussed yesterday young means, I do not know, young means I can say 70 years person is also young. It depends upon his, okay, means how he feels. I may be old, but I may feel I am young. Okay? So, that is why this young depends upon you that you define. Okay? So, suppose this young I define if it belongs to 0 to 80 years. This is my choice. Okay? 0 to 80. Okay? Now, let us see what is happening. If it is 0 to 80, so now if I plot this side x, this is your mu A bar x membership. Okay? So, membership values will be from 0 to 1, okay, 0 to 1. So, now if it is 0, so we have up to 80. So, suppose 10, 20, 30, 40, 50, 60, 70, 80. Okay. See the range from 0 to 80 I am considering as young. So, what you say about suppose I take 30 years old, because you are taking 0 to 80 as young. Okay. So, 30 should be what? In that case 30 should be very young, means in that range very young. So, 30 should be near to 0.9, should be near to 0.9 for this range 0 to 80. So, suppose it is 0.9, so it will be near to 1, 0.9, so 30, so here, okay. So, see if I plot it 10, tell me 10, for 10 it will be maybe 0.99, it is very young, understanding. Suppose I take 1, it is very near, very young, actually infant, okay. So, 10 for, okay, 10 it will be 0.999, 0.99 in between this. Suppose I take 70, for this case 70 may be near to here 0.1 or 0.2 or 0.11 like that, okay. So, now if I plot it as a continuous function, so see the plot will be actually more or less like this, it will be go here, then it will be like this, see roughly, okay, you are understanding. So, this you have taken 0 to 80 range as the young as per your choice. Now, if I change this, now I change this as A1 bar, one fuzzy set. So, this is the plot for A1 bar, okay, A1 bar. Now, if I take another fuzzy set A2 bar as very young, okay, and we say that this very young belongs to the range 0 to 50, okay, very young I take as 0 to 50. Now, tell me for 30 now what should be, means roughly what should be approximately the membership function for this very young. Yes, it should be 0.5, no, half, around half. I can say 0.6 also, 0.5, but 0.5 is okay, good estimate. So, I can have then 0.5, here 0.5. So, this is the case. We are understanding the change of this membership functions as per this range and all, okay. So, now this plot will be like this, and then it will go to just like this, okay. So, this is your A2 fuzzy number, okay. So, now you see I have mu A1 bar at suppose 30, this is your 0.9, and if I say mu A2 bar 30, it is your 0.5, okay. So, that means you are seeing the fuzziness, okay, how it differs depending upon your choice of this, choice of how you define the fuzzy number, fuzzy set, okay. So, in this way you can generate your own, okay. That is why we have many flexibility in this modeling, okay, depending upon your problems, okay. Let us come to the third example, okay. Can I erase? So, now come to another example. Now, I define a fuzzy set A bar real number close to 0, that is my fuzzy set, okay. Now, see what is happening. So, here we should have some membership function to define that, okay. Suppose I define this mu A bar x as 1 by 1 plus x square, okay. That means at x is equal to 0, I have the membership function as 1, this value, okay. At x equal to 1, I have the membership value as 1. Pardon? So, x equal to 0, sorry, x equal to 0. Now, see the plot. So, at 0, okay, it is close to 0. So, I have the membership function from 0 to 1. Okay. Now, I plot this for different real number, or suppose I take this side 1, 2, 3, this side -1, -2, -3. Okay. So, for 1 I have mu a bar 1 will be what? Mu a bar 1 will be 0.5, okay, 0.5. Okay. So, similarly mu a bar 2 will be what? 0.2. Okay. So, in this way you can find all those membership functions by this formula. Okay. So, now if you see, for 1 I have 0.5, I have 0.5. Okay. So, for 1 I have 0.5, but at 0 it is 1, at 2 it is 0.25, same -2, same -1 because square is there. Okay. So, our plot will be how like this. Understanding? So, this is the fuzzy set when you have real number close to 0. Okay. Understood? If you see 2, it is near to 0.25, 3 accordingly go to plus infinity and minus infinity, you have the plot like this. Okay. So, now in the next example, if I change this example to real number very close to 0, see we have the game of very close, very close, okay, very hot, okay, like that. So, real number close to very close to 0. Now, next example 4, na? Real number very close to 0. Now, if it is very close to 0, so then we have to define now the membership function accordingly. In this case, very close to 0, that means we can define this as mu a bar x is equal to 1 by 1 plus x square whole square. Now, you see what you are getting. So, in this case mu a bar 1 will be what? 0.25. You see the change? See the change, very close to 0. Earlier it was close to 0. We had mu a bar 1 as 0.5, if you remember. Mu a bar 1 as 0.5. Now it becomes mu a bar 1 as 0.25. Let us draw this. So, it is 0 to 1, 1, 2, 3, minus 1, minus 2, minus 3. Okay. So, now at 1 it is 0.25. So, 0.25 may be here. So, it is 0.25. Okay. So, at 1 it is 0.25. So, now this will be what? It will come directly here. It will also come directly here and it will go like this. Understanding? The width is decreasing because it is very close to 0. Okay. So, you can write the fuzzy set like that also, 2 component wise ordered pair as maybe 0, what is the value 0, 0, 1 like that, 2 we can write like that also. So, this is the plot for this very fuzzy set. Okay. Now, comes to another example, actually that is very important to define some terms in fuzzy set. So, consider a universal set X, consider a universal set X which is defined on the age domain. So, our universal set, so these are age of different persons, okay, 5, 15, 25, 35, 45, 55, 65, 75, 85. Okay. So, we have the age from 5 to 85. Okay. Now, we define 5 or 4 fuzzy sets. So, I define fuzzy sets. First one is infant, second one as young, third one adult, fourth one senior on this universal set. Understood? These are 4 different fuzzy sets. Okay? Infant, young, adult, senior. I have this as the universal set. I have these ages 5 to 85. Okay? Now let us draw a table, means make a table. So here we are giving age, here we are having infant, okay? Then we have young, adult, senior. Okay? So we have 5, 15, 25, 35, 45, 55, 65, 75, 85. These are the ages. Now take first this infant fuzzy set and place the membership values as per your choice. Okay? So infant, we say 0, we say means it is not there. Okay? So all the membership values are 0. Okay? So here all are 0. Okay? Come to the next fuzzy set, young. Young. So young, it depends from where you start. So where you want to start? Suppose I start from 15. Okay? So then 5 should be 0. So if I start from young, so maybe then 15 I can put at 0.2. Okay? So youngest will be where? 35 maybe. 35 you may consider as the young man. Okay? So I can have this 35 as 1 or not. So let us put this as 1 first. Now 25 I can have 0.8 because 25 is very also young. Okay? You can put 0.9 also, no problem. So it is 0.8. So if 35 1, 45 also you think it is young, but less than this 35. So if they both run, so 35 will win or not. So maybe 0.6, yes, okay, we will put 0.6. 55. So I am not so old or not. So I can put how much? I can run with anyone, no problem. So it is 55 is, I should put what? 0.5, okay, let us put 0.5. And 65, okay, after retirement, so it should be 0.1 or 0.2, otherwise all these knees will go, okay. So it will be maybe 0.1 or 0.2, let us put 0.1. But 75, 85, those should be 0 or not? Those should be 0. So you are understanding how you are giving the membership values to the fuzzy set, this young. Come to the adult. See, you have adult movies. So after what age? At least 18. So adult, this means 5 and 15 should be 0 or not? So 5, 15, 0. Again 25, yes, you can take it, that is adult. So I can have 0.8, okay, or 0.9, 0.9 also I can take. 25 is adult enough. No, let us take 0.8. 35 is 1 or 0.9? 0.9. So I can take, then this is 1, 45. Okay? Then 55, 65, all are what? 0 or 1? 1. Up to all these should be 1, all are adult, na? 85 also can see adult movies or not? Yes. So should be 1 all. 1, 1, 1, 1. So see the change.
But these may fall in senior category.
No, see, I am coming to the senior category now. This may fall.
How we define adult? It depends.
No, it depends upon your choice. No, adult will be, suppose I can take sometime 15, 16 also adult. Earlier 16 was adult. So from 16 I can start. But adult is up to here. So that's why I told in the first class that fuzzy sets you don't have the exact boundary, overlapping is there. This is the overlapping. This fuzzy set and this fuzzy set, some points will be overlapped. Here also, maybe somewhere it is overlapped. Okay? So those things we have to handle accordingly. Okay? We have different methods to handle those. Okay? That's why it is interesting, because see, in nature or in any differential equation, it is not exactly actually, no? Okay, so if we can model that, suppose one problem, suppose A is fuzzy set, suppose in terms of mathematics, if A we can have fuzzy matrix. So till date this is an open question to find A inverse. Till now it is not no method is there to find the inverse of a fuzzy or interval matrix. Okay. So there are many challenges there. So anyway, so come to senior. So senior, as you know, trend reservations starts from 60. Okay, 60. So here 50. We have taken. We can include 60 also. So let us take 55, or 55 is maybe senior. So I can give there at 0.2 or 0.3. Okay. So let us give 0.5 55 as 0.3. But before that is these are all 0 or not. They will not get concession in trend or not. So these are all 0. So now this is 0.3. So 65 is what? 0.9 or 0.99 or whatever. So I can take 0.9 and then 1. Understood? So how to make these fuzzy sets? Okay. Now it is clear about how we will give membership, and this is not means you can change this 0.2 to maybe 0.25, 0.3. You can say, sir, then answer will be different. If I go to the other solutions, etc., other problems, answer will be maybe different, but it will be in the range. Okay, because suppose in practical application also, suppose I want to design something. So design means what? Means factor of safety. Okay, so factor of safety again should not be a single digit, because for design if you have some force and how it fails, etc., I do not know about the force. So how it fails also I do not know, and when it will fail that also do not know, then I should give some range, from this to this. See the application. I should not have a single digit that if this is crossed then it will fail. Maybe that before that it will fail or after that it will fail. So it is better to give some range. Okay. So that is why very interesting and very powerful this method are. Okay. So now from here I will define some terms actually. Okay. So from here I define first support of fuzzy set, and we define this support by S bar. Bar I am using for showing the fuzziness. Okay. Support of a fuzzy set A bar is defined as X such that mu A bar X greater than 0. Okay. You understanding? Support of a fuzzy set defined as those elements for which membership function value is greater than 0. Okay. That means support should be a fuzzy set or crisp set? Crisp set. That means support of a fuzzy set will be a crisp, because these are all x values or not. So this is a crisp set. Okay. Now let us see what is happening here. Support of Young, because Young is a fuzzy set, support of Young are what? It is telling all greater than 0. So support of Young starts from 0.2 up to 0.1. So 0.2 is 15 to what is for this 65 I think, no? So it is 15 to 65, 15, 25 up to 65. This is the support of Young fuzzy set. Understood? Similarly, if I find support of adult greater than 0, so adult will start from 0.8 up to here 85. So see, it is 25 to 85. See, this set is a crisp set. Okay. So support of a fuzzy set is a crisp set. Okay. Similarly, I can have support of senior, and this is starting from here. So it is 65, no, 55. Okay, this okay 55 to 85. Okay. What about support of infant? It is empty because I do not have any values greater than 0. Okay. The support of infant is empty set. Okay. This you have understood, support of a fuzzy set. Okay. Now erasing this. Now I will define next term, that is height. This is defined as the maximum value of the membership function. Maximum membership degree or whatever. Okay. Okay. So what is the height of this fuzzy set? 1. Okay. This is also 1, this is also 1. Sometimes you may not have 1. Okay. You may not give 1 to all the elements. It depends upon your application. Here it should be 1, but there are some applications problems that you may not have 1. So height is the maximum value. Now from here we define as normalized fuzzy set. Normalized fuzzy set. And as we know, what about normalized means? That means maximum value, if you have 1, if you have 1 as maximum value, then that means if height is 1, then that fuzzy set will be called as normalized fuzzy set. Understood? So in this case all these 3 are normalized fuzzy set. So height is 1. Understood? So if I draw, suppose for a continuous system, so suppose it is 0 and it is 1. So if you have like this fuzzy set, so this is your 1, so this is your height, this is non-normalized. This is non-normalized because you do not have the height, it is not reaching up to 1. So this is non-normalized. Similarly, if I have 0 to 1 and this is, if suppose I have like this, so it is normalized. Understood? Normalized and non-normalized and height. So now you have understood support, height, normalized fuzzy set. Now come to alpha level set. Normalized set, what is the maximum value? 1 is not there, so it is not normalized. No, we cannot do normalization always. We cannot do. How you can 0 by 0 it will come, na? Okay? 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 Now come to alpha cut or alpha level sets. Alpha cut or alpha cut or alpha level. So here we define again like this, A bar alpha. A bar is the fuzzy set and alpha is this alpha. So this is defined as x such that mu A bar x greater than equal to, understood, those elements for which this membership function is greater than or equal to alpha, and alpha is arbitrary. Alpha is arbitrary but in 0 1. Okay? So if I want to find for this fuzzy set young, so again you see alpha cut set will be a crisp set. Alpha cut will be a crisp set or alpha level will be a crisp set. Okay? So now young 0.2, what will be that set? Young 0.2, it should be greater than or equal to 0.2. So that means it should be from here to here. So it is from 15 to 0.1, we give 65, no? 65, sure? So 15 to 65. Okay? If I use 0.4, so it will be from 25 to 55. It is 0.1, na? 55, na? 25 to 55. Is it okay? So similarly, we can define for other fuzzy sets with other alpha values. Okay, only thing you have to check greater than equal to alpha. Okay. So, this is your alpha cut. So, similarly we can have a strong alpha cut, and you can imagine the definition will be then greater than alpha. Okay. So, let us write that strong. So, the definition will be A bar. I will now define alpha, strong alpha as alpha dash, just notation to distinguish alpha as alpha cut and alpha dash as strong alpha cut. Okay. So, this will be defined as x such that mu A bar x greater than alpha dash. Okay. Understood? So, similarly you can find if it is greater than 0.2. So, you will have from here 25 to 65. So, if I have young 0.2 dash I could write is equal to 25, no, 25 to 55, yes, 25 to 55. Okay. Okay, clear? So, now suppose for alpha cut set, if you have alpha 1 greater than alpha 2, suppose alpha 1 is the value of alpha and I want to find A bar alpha 1 and A bar alpha 2 corresponding alpha set, alpha cut set. Okay. So, what should be the relation? It should be, means it should be a subset. Understood? If your alpha 1 greater than alpha 2, then A bar alpha 1 subset of A bar alpha 2. Okay. So, this we can very well see by a figure that what is happening, you can see. So, if I have, suppose this is a fuzzy set. Okay. So, if I have, this is alpha 1, this is alpha 2, I told alpha 1 greater than alpha 2. Okay. This is your membership function. Okay. So, alpha 1 greater than alpha 2. So, now alpha 1, what are the x? This for A bar alpha 1, and for alpha 2 you see this is your A bar alpha 2, and you see A bar alpha 1 contained in A bar alpha 2. Okay. So, okay, I think in the next class we will see the further definitions and other operations of fuzzy set.